Hello students, welcome to the channel. In the Basics Explained series, we look at the fundamentals of the math that you need for the SAT and ACT. Today's video, we look at triangles. So let's begin by looking at angle relationships. Let's say I have two intersecting lines like this, right? Then this angle and this angle are called vertically opposite angles. And for any pair of intersecting lines, these angles are equal. Similarly, this angle and this angle are vertically opposite angles, and they would also be equal. Okay, what about corresponding alternate interior and same side interior angles? What do they mean? Let's say I have a pair of parallel lines and I have a line that goes transverse through them. Then this angle and this angle, these are called corresponding angles, and they are always equal. What about alternate interior angles? This angle and this angle are called alternate interior angles, and they are also equal. What about same side interior angles? This angle and this angle are called same side interior angles, and they sum to 180 degrees. So these are some of the properties of angles around parallel lines that you need to know. Okay, by definition, complementary angles are angles that sum to 90 degrees, and supplementary angles are angles that sum to 180 degrees. For example, 30 and 60 are complementary, and 30 and 150 are supplementary. Okay, so let's do this sample question. In the figure above, lines L and M are parallel and lines S and T are parallel. If the measure of angle 1 is 35, what is the measure of angle 2? Okay, so this is 35, right? And since these two lines are parallel, this also is 35, right? What will this angle then be? This angle will be 145 because these both are angles on a straight line, so their sum should be 180. And then this and this are parallel. So this and angle 2 are corresponding angles. They should be equal. So angle 2 is 145 degrees. Option D. Okay, now let's look at triangle properties. A triangle is basically a three-sided figure as shown here. The most important property that you would need is that the sum of angles of a triangle is 180 degrees. Now, the normal notation is that if you have a triangle ABC, then the side opposite angle A is denoted by small a, the side opposite angle B is denoted by small b, and the side opposite angle C is denoted by small c. So if A, B, and C are the sides of a triangle, then any side of the triangle, any side is greater than the difference of the other two sides, and it is less than the sum of the other two sides, right? So let's say I'm working with A, then A would be less than the difference of B and would be greater than the difference of B and C, and it would be less than the sum of B and C, right? So let's say I have a triangle like this, where this side is 20 and this side is 7, and I need to find the range of the third side. So let's say the third side is x. So x will be greater than 20 minus 7, which is 13. And it would be less than 20 plus 7, which is 27. So x can lie between 13 and 27. Remember, 13 and 27 themselves are not included. So it's only between those two numbers that x can lie. Okay, then we have something called the sine rule for a triangle, which says that the ratio of a side to the sine of the angle opposite that side is equal for a triangle. So A divided by sine A is B divided by sine B and is C divided by sine C, right? This is often tested on ACT, and I have a separate video on sine and cosine rules and ACT questions related to this. So do check that out. I'll link to it in the description box. Okay, the cosine rule is a handy rule if you are given the sides of a triangle and you need to find any angle. So let's say I'm given A, B, and C, the small a, B, and C, which are the sides of a triangle. Then cos A, the cos of this angle, is B squared plus C squared minus A squared over 2BC. Cos of B is A squared plus C squared minus B squared over 2AC. And cos of C is A squared plus B squared minus C squared over 2AB. So there's this pattern that follows, right? So if you remember the cosine rule, you can find any angle when the sides of a triangle are given. Again, how do you apply it is something that you can watch in the sine and cosine rules video. Okay. Now, what are the key terms related to a triangle? Let's try and understand. So let's say this is my triangle, right? Let's call it A, B, and C. Now, the median is the line segment that joins any vertex to the midpoint of the opposite side, right? So here BD is equal to DC. In that case, AD is the median, right? So any line that joins the vertex to the midpoint of the opposite side is the median. What about the altitude? The altitude is the perpendicular from the vertex to a side, right? So when you drop a perpendicular from a vertex to any side, that's called the altitude. And the area of a triangle is given by half base into altitude, which is normally denoted by h. So let me write that. Half base into height. So in this case, I can say it's half BC into A. Let me call this MAM, right? Half BC into AM. So this formula works for any combination of base and height. So if I had taken AC as my base, then I could take the altitude from B to AC for H and so on. Okay, what is an isosceles triangle? An isosceles triangle is a triangle in which two sides are equal, right? These two sides are equal. And since these two sides are equal, the angles opposite them are also equal, right? That's an isosceles triangle. An equilateral triangle is a triangle in which all the three sides are equal, which means that the every angle in an equilateral triangle is 60 degrees. And the area of an equilateral triangle is given by root 3 by 4a square, where a is the side of the equilateral triangle. And there is another kind of triangle, which is the scalene triangle, where all the sides have different lengths. That's called a scalene triangle. Okay, what are similar and congruent triangles? Similar triangles are triangles that have the same shape, but they have different sizes, right? So I can say that triangle ABC, I can say that triangle ABC is similar to triangle DEF when angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. So the corresponding angles are equal. Also, AB by DE is equal to BC by EF, and that is equal to AC by DF. So the ratio of the corresponding sides is also equal, right? That's the property of similar triangles. Congruent triangles are just copies of one another, right? They are absolute mirror images of one another. So if I say that triangle ABC and DEF are congruent, then I write it like this. Triangle ABC is congruent to triangle DEF. And here, angle A is angle D, right? Angle B is angle E. Angle C is angle F, right? So obviously the corresponding angles are equal, but even the corresponding sides are equal. So AB is DE, BC is EF, and AC is DF, right? So they are just mirror images of one another. Okay, what about Pythagoras theorem? We know that if you have a right triangle, that means one angle is 90 degrees. Let's say this is A, B, C, and this is A, this is B, and this is C. Then the square of the hypotenuse, which is small a square, is the sum of the squares of the other two sides, right? That is what the Pythagoras theorem says. And then you obviously have trigonometric ratios. Let's draw a right triangle, right? Let's say this angle is theta. Then this is called adjacent side. This is called opposite side. Okay, let me write it as O. Yeah, O. And this is called the hypotenuse. So sine of theta is opposite over hypotenuse. Cos of theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. Right? I have a more detailed video on trigonometry. I'll link to that in the description box. So do check that out. Right? So this is just a basic primer on the trigonometric ratios that you need to know. Okay, so let's do this sample question. Which of the following additional measurements to the triangle provides enough information to determine the length of AB? So here we have a triangle ABC where angle A is a right angle and the hypotenuse 25 is given. And I need to find the length of AB. So which additional piece of information? So if they give me the length of AC, then I can use Pythagoras theorem, right? So with Pythagoras, I can find AB. So this is enough. And if they give me the measure of angle ABC, if they give me the measure of this angle, then I can say cos of that theta is AB by 25. So AB is 25 cos theta, right? So I can also find it with this. So with either 1 or 2, I can find the length of AB, and so the answer is C. Okay. Another sample question. In triangle ABC, angle C is 90 degrees. Okay. So angle C is 90 degrees and AB is 12. Squares BCXY and ACWZ. BCXY. Okay, so I'm drawing a square like this. BCXY and ACWZ. Okay. Are constructed outside of the triangle. What is the sum of the areas of the square? So let this side be X and let this side be Y. Then the area of this square would be X square. And the area of this square would be Y square, right? Because the area is the square of a side. So what is the sum of the areas of the square? X square plus Y square. What is that? And we know that in this right triangle, X square plus Y square using Pythagoras theorem would be the square of 12. So the right answer is 144. The sum of the areas of the squares would be 144. Okay, this question. In the figure above, AD intersects BE at C. If X is 100, what is the value of Y? Okay, so X is given as 100. So what is the sum of angles of this triangle? 180. So this angle will become 60. Since this is 60, this is also 60, vertically opposite angles. So the sum of angles here has to be 180. So 100 plus 80. So Y has to be 80. Option C. Okay, question 5. In the figure above, what is the perimeter of parallelogram ABCD? Okay, so we are given this angle 45 and we are given the coordinates of point C, right? So what does that tell me? If I drop a perpendicular like this, then it tells me that this distance is 8 and this distance is 3, right? If this is 45, then this angle is also 45 because these two lines are parallel. So these are corresponding angles. And if this is 45, this is 90, then this also is 45, right? So this is a 45, 45, 90 triangle, which means that if this is 3, then let me call this M, then DM is also 3, right? If DM is 3, then AD has to be 5 because AM is 8. If AD is 5, then BC is also 5 because opposite sides of a parallelogram. Now, what about DC? DC is the hypotenuse of a right triangle with sides 3 and 3. So this would be 3 root 2. And so AB will also be 3 root 2. So what is the perimeter? It is 5 into 2 plus 3 root 2 into 2, which is 10 plus 6 root 2, option B. Okay. Sample question 6. Point P is the center of the circle in the figure above. What is the value of X? Okay, so we are given these two angles, 20 and 20. So let me join this, right? Now this is the radius of the circle and this is also the radius. So this becomes an isosceles triangle, which means this angle is also 20. Similarly, this is 20, so this angle is also 20. So BAC, angle BAC becomes 40 degrees, right? Now, the circle property is that the angle at the center is twice the angle on the circumference, right? So that means X will have to be 80 degrees. And so the answer is 80. Right, so that was the basics of triangles that you need for SAT and ACT. Hope this was useful. I would also link to some other videos where we have solved advanced triangle problems. So do check those out. Let me know in the comment section what other concepts you would like me to take up in future videos. I'll see you guys again soon. Take care. Bye-bye.